Today's class is going to start off with a review. In our previous lessons, were writing linear equations. We started off by writing them based on a line that was graphed. We were given the slope and intercept. We were given the slope and a point on the line. We were given 2 points on a line. And we talked a little bit, I believe, about parallel and perpendicular lines. We then went into standard form, but let's start off with slope-intercept form. Y is equal to mx plus b. We know that m is the variable that represents our slope, and b is the variable that represents our y-intercept. When we're given all the information that we need, we just simply replace those two variables, and we have our line. So in this first one, when you are given the slope and the y-intercept, we simply have y is equal to 4 times x minus 3. Slope is 4, y-intercept negative 3. We then found that we were sometimes given the slope and a point. This is our x and y coordinate. So we can take that and replace it into the model. So I have 8 is equal to negative 3 times negative 2, and we're solving for a y-intercept. 8 is equal to 6 plus b. If we subtract, we get a y-intercept of 2. Now that we have a y-intercept, we have exactly what we need to write this line. Negative 3x plus 2. We went one step further and we said, what happens when you're not given the slope or the y-intercept? We have to start by calculating slope. That's my y2 minus y1. It's the change in y over the change in x. I have negative 10 minus a negative 2. My change in x would be 6 minus 4. Watching our signs, we add the opposite. That's going to give me negative 8 over 2, which simplifies to negative 4. Now that I have my slope, I need a y-intercept. So I'll choose a point, either coordinate ordered pair, and I'll take negative 2 is equal to my slope, negative 4, my y coordinate 4, and we're solving for b. Negative 2 is equal to negative 16 plus b. Add 16 to both sides, and I get b is equal to 14. Once I have slope and I have a y-intercept, I can easily write my equation in slope-intercept form. And hopefully this is all very familiar to you. We then went into discussion about parallel lines. Now we know parallel lines are two lines that never intersect, but we also know they have the same slope but different y-intercepts. If you're given a line and you're told that you want to find a line that's parallel that goes through a given set of points, we then only need our slope. And then we use this point to find our y-intercept. So now we have y is equal to negative 3x plus 4, times 4 plus b. I simplify. I then go ahead and add 12 to both sides, and I see that b is equal to 10. So now my line that is parallel would be y is equal to negative 3x, same slope, different y-intercept. Those two lines will flow side by side but never intersect. Let's try one more. I have a line here, but it's not in slope-intercept form. So the first thing I need to do is rewrite this, and this becomes very important that you identify your slope, and if it's not in the correct form, you need to rewrite it. So we know that our slope is equal to 2. Now we can find our y-intercept. Y is equal to m times x plus b. We'll subtract 12 on both sides, and we'll see that b is equal to negative 16. So the line that is parallel to 2x plus 7 would be y is equal to 2x minus 16. Same slope, different y-intercepts. We then talked about, let's just skip over to this before I go back to standard form. If I wanted to write an equation of a line when I'm given a graphed line, I start by identifying two pieces of information, my slope and my y-intercept. Well, we know y-intercept is a point on the y-axis. I'm counting up 1, 2, 3. I then find those 2 points that are connected at a corner and count up. In this case, it's positive, up 1 and over 1, 2, 3, 4, 5, up 1, 1, 2, 3, 4, 5. Okay, so we see that those points all fall there, so that my slope is 1/5. Equation, y is equal to 1/5 x plus 3. And there's something about this line already. It has a negative slope. So I know when I'm calculating my slope, I should remember that it's negative. My y-intercept is right at the origin. My slope is going down 1, 2, and over 1. It's a negative 2 slope. This is a model of direct variation because it crosses or passes through the origin. Now let's just go back for a moment to standard form. If I want to write an equation in standard form, ax plus by equals c, we will be sure that we have to move this x term over to the left. I'm going to be adding it to both sides. I now have that 3x plus y equals 4. Getting it in the form of ax plus by equals c, we need to move the constant in this direction and the x term in that. So I'm going to have to do a little bit of movement here. I'm going to be subtracting 4x. I'm going to be adding 6. Now we talked about two forms, one form being with the negative as the leading coefficient, or I could multiply everything by -1, and this would be the second form. There's one other thing I didn't talk about, is how we want to have our leading coefficient as an integer, and I will get into that in our next session. I'm not sure if we had discussed perpendicular lines, so I'm going to leave that one to discuss in class today. And today was basically all about the review. I hope it was helpful.